Hey guys, how's it going? Today we're going to be learning about percent composition and empirical formulas so that they actually make sense. Let's jump right into it. First, we need to know a couple definitions before we get started. So for percent composition, we're obviously dealing with percentages, and it's what percent of a compound's mass, maybe like H2O, comes from each element. And it's basically just saying, okay, if we have H2O, what percent of the compound is made up of hydrogen molecules, and what percent of the compound is made up of oxygen. And I'll show you how to work on that in the problem we do after this. And for empirical formula, that would just be the simplest whole number ratio of the elements present in a compound. So just literally just H2O. Or you could do like glucose, which is just C6H12O6, something like that. And then the 6, 12, and 6 are the simplest whole number ratios. All right, now on to some example problems. So say we're given the formula of H2O, and we need to solve for the percent composition. So we have H2O, and we know that H2O is made up of 2 hydrogens and 1 oxygen. So we'll write hydrogen here, and we'll write oxygen here. And we need to know what the molar mass of each is in order to find the percent composition. So we'll say, okay, we already have a 1.01 molar mass for hydrogen and a 16.00 molar mass for oxygen. So it would just be grams over mole, and then grams over mole. And then in order to find what percentage it makes up, we need to multiply that by however many moles of it there are. So there's 2 moles of hydrogen, which would give us 2 grams of hydrogen. And then we have 16 grams of oxygen, and there's only 1 mole of oxygen. So this would just give us 16 grams and 2 grams. And you're like, okay, that's not a percentage. How do I find the percentage? What you're going to have to do is actually add these two, because that's going to be the total mass of the H2O molecule. So it's going to be 18 grams. And then from there, you simply just have to divide. So you're going to say, okay, for hydrogen, it's 2 grams that are making up this 18 grams. And you need to divide that by the total, which is 18 grams. And that's going to give us a percent composition of about 11.1% or 11.2%. And then for oxygen, same thing. We're going to say, okay, well, what was the mass of oxygen in this problem? It was 16 grams. And then out of how many grams? 18. And that'll give us a percent composition of 88.8%. So in all, hydrogen makes up 11.2% of this compound, and oxygen makes up 88.8%. And you notice, okay, there's 2 moles of hydrogen and only 1 mole of oxygen. How does oxygen make up more? It's because it has a higher molar mass, meaning it just takes up more space, more mass, right? And that's why it takes up more of the percent composition. All right, let's move on to empirical formula. So in this problem, we're given a 100-gram sample which is made up of 40% carbon, 6.7% hydrogen, and 53.3% of oxygen. So now we need to find the simplest whole number ratio of the compound given before us. So we're given a 100-gram sample, and we have 40% carbon. So we'll just start off and just write the molecules we have, or the elements we have. So we have carbon, we have hydrogen, and we have oxygen. In carbon, we are given 40. In this scenario, since it's 100 grams, we can simply just convert these to grams, right? Or the percentages to grams. So we'll say 40 is 40 grams, right? And then hydrogen, we'll just have 6.7 grams. For oxygen, we'll have 53.3 grams. And from there, we need to divide by their molar masses in order to convert these to moles, because now they're in grams, we have to divide by molar masses. So we can just put each of these over 1 and multiply them and say, okay. And this is the same thing as division. So we're going to put moles on top because that's what we're trying to get to. So we're going to say, okay, 1 mole of carbon. And then on the bottom, it's going to be grams. So it's 12.01 because that's the grams of carbon. You could also look at it just 40 over 12, and that'll give you your answer. And from there, we're just going to get 3.33 moles. And then for hydrogen, we're just going to put this over 1, multiply it, and we know that hydrogen has a molar mass of 1.01, so that's going to go on the bottom, and 1 mole of hydrogen on top. And from there, we will get 6.65 moles. And then for oxygen, we're just going to set that over 1 as well, and we're going to divide or multiply by the molar mass again, which is 1 mole of oxygen, and then we have 16.0 grams, which gives us a total of 3.33 moles. And then from here, you usually just divide by the smallest. So you say, okay, in this problem, we see 3.33 moles is the smallest. We're only looking at the moles now, so just these three. Right, so let me write them again. So just 3.33 moles for carbon, 6.665, and then 3.33 moles. And from here, like I said, so you divide by the smallest. So it's going to be 3.33, and that gives us 1. And then from this, that would give us 2. And then the same down here, this would give us 1. And then every time you just want to divide all of them by the smallest common denominator, or the smallest number that you see out of all of the mole values that you get. And in this instance, it was 3.33. So then from there, you can write your empirical formula, which is just going to be C1H2O1. And that was given from these numbers right here, which we solved taking the grams, dividing it by the molar mass, giving us a mole value, and then dividing each mole value by the smallest mole value that we were given. And that's how you do empirical formula and percent composition, guys. I hope you enjoyed the video. If you want me to teach you anything else, just let me know. Go ahead and like and comment and subscribe if you enjoyed it. And stay tuned for more videos, guys. Have a great rest of your day.